Section 1.6 is absolute value, equations, and inequalities. Learning targets for this section are I can write and solve equations involving absolute value, and in the second half we're going to write and solve inequalities involving absolute value. Big ideas for this section. An absolute value quantity is non-negative. Since opposites have the same absolute value, and absolute value equations can have two solutions. Absolute value inequalities can be written as compound inequalities without absolute value signs. Take note on page 41 tells us that absolute value is a distance. So if we have the absolute value of a equals 5, for example, that's telling us that the distance away from 0 is 5. And that can be here to positive 5 or here to negative 5. So our a value could be 5, or it could have been negative 5. And those are the two things that give us an absolute value. Remember, absolute value is non-negative. It's our distance of 5, for example. So in example 1, the solution here, and then graph it. So 2x minus 1 could equal 5. That's one of our options, that when we take the absolute value, it could have been 5 in order to get 5. Or whatever's inside the 2x minus 1 could have been negative 5, because when we take the absolute value of negative 5, we also get 5. So we have two different options here. Anytime we have absolute value, unless it's equal to 0, we have two options. We're going to solve each equation. First, we're going to add or subtract, then multiply or divide. Same thing here, add or subtract, then multiply or divide. So my solutions are x could have been 3 or x could have been negative 2 in order for us to get 5. Now to graph it, at 3, a number on each side, negative 2, a number on each side, and 0 here in the middle. I'm going to put a circle at 3, and I'm going to fill it in because it's equal to. We always fill in equal to. I'm going to put a circle at negative 2, and I'm going to fill it in. Now, we don't shade anywhere here, guys, because we don't have anything to tell us direction to shade. Also, it's only these 2 points, and that is all that make that equation true. So 2 points, we fill them in because it's equal to, just like we do if it's less than or equal to or greater than or equal to. But here we just have those 2 points. Feel free to pause here and give this a try if you'd like. Again, we take whatever's inside, and when we took the absolute value of that, it could have been 4 in order to get 4. Or whatever's inside our absolute value, it could have been negative 4, because when we take the absolute value of negative 4 is also 4. Again, we solve each equation, and here it's an or, by adding or subtracting first, and then multiplying or dividing. Adding or subtracting first, and then multiplying or dividing. Again, we're trying to get that variable by itself. So the options here that can make this equation true are if we had 2/3 or if we plugged in negative 2. Either way, we would get an absolute value of 4. Again, as far as the graph goes, I'm going to graph each point, fill in my circle, and we don't shade anywhere because it's only these 2 exact points that will work. In example 2 here, we have a lot going on with this equation. The first thing we need to do, though, is get our absolute value by itself. I'm going to solve for my absolute value, because we can't figure out what was inside our absolute value until we know what it equals. And here, that's going to change because we have the minus 1 and the plus 3. So I'm going to add 1 first. Again, we're just isolating our absolute value. If you want, rewrite it as 3 times a for absolute value, minus 1 equals 8, and then solve for a. Plug back your absolute value. Now, since I'm solving for my absolute value, it's being multiplied, I'm going to divide. Now that we know what our absolute value equals, or what it could have been, we take what's inside and that could have been 3, or what's inside could have equaled -3, because then we took the absolute value of it. Solve by subtracting 2. And I get 1 or -5. As far as graphs go, at 1, I have a circle, and I'm going to fill it in because it's equal to. And at -5, I have a point, and I fill it in because it's equal to. And because it's equal and not less than or greater than, there's nothing else I can do on my graph. Feel free to pause here and give this one a try if you'd like. Again, I'm going to get my absolute value alone first. I can't figure out what could have been inside there until I know what my absolute value itself equals. So I'm going to subtract a 3. And divide by 2. And now all I have is that absolute value equals 2, which means my x plus 9 could have equaled 2, or my x plus 9 could have been -2, and then I took the absolute value to get to 2. So here we solve each equation. And I could have had -7 or -11 in order to make that equation true. And those are the only two options. As far as the graph goes, one number on each side. I put a point and fill it in at -11, and a circle or a point at -7 and fill it in. Some absolute value equations have no solution because absolute value represents a distance, and distance cannot be negative. Therefore, it's important to check the possible solutions of an absolute value equation. One or more possible solutions may be an extraneous solution, which is a solution derived from an original equation that is not a solution of the original equation. And this is a little bit different, guys, than when you've plugged things in before and just seen that things were wrong because you did something wrong with your math. Here you do all the math right, but when we plug it back in, because a variable can change, it makes it equal to a negative number, and we can't have that. The other thing here, guys, is if we have an absolute value, let's say x plus 2, equal to -5, we know right away that this is a no solution. Because absolute value, if it's the only thing, cannot equal a negative number. So I know as math teachers we always say check your answers, plug them back in and check your answers to make sure that you did it right. This is different. When we're talking about extraneous solutions, guys, you could have done all the math right, but one of the answers still doesn't work. And so you always, always, always have to check anytime your absolute value equals a variable. Every single time you need to check, because depending on the value of that variable that you get for x, sometimes it's going to make the other side negative. And if it's negative, it means no solution. So we're going to take whatever's inside our absolute value, 3x plus 2, could have equaled 4x plus 5, or 3x plus 2 could have equaled its opposite. And in order to find the opposite, we take the opposite of the entire thing. It's like we multiply by a -1. So minus 4x minus 5. We take the opposite of the entire side. Now we're going to solve here. So I'm going to get all my variables together on one side. And then isolate my variable by subtracting. And I get -3 for x. Over here, get all my variables together on one side. Now I'm going to try and get my x by itself, first by subtracting, and then by dividing. So x could have been -3, or x could have been -1. Now we need to check for extraneous solutions, and in order to do that, we plug into our very original equation with the absolute value, the one in the book, the one we started with, the one on the test, the quiz, wherever it is, the original equation, each answer. So I'm going to take the absolute value of 3 times -3 plus 2 equals 4 times -3 plus 5, and check. I get -9 plus 2, -7. take the absolute value, and I get 7 equals negative 12 plus 5, negative 7. Can 7 equal negative 7? No, they're not the same, but that does give us an indication that it's an extraneous solution because our sides are opposites. So without our absolute value, we would have had negative 7 equals negative 7. It shows us we did our math right. This answer just doesn't work. So as far as showing me that, I want you just to cross it off or write that it's extraneous. Now let's check our second one. 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. Negative 3 plus 2, negative 1. Take my absolute value, I get 1. Negative 4 plus 5 gives me 1. 1 does equal 1. So x equals 1 is a solution. When we do this, guys, there's not like a hard, fast rule on sometimes there's 0, sometimes there's 2, sometimes there's 1. It's not always the smaller one or the bigger one or the negative one or the positive one. You just have to check them. So like I said, sometimes they'll both work, sometimes neither will work, sometimes just one. And the big thing to look for as far as extraneous is anytime it equals, absolute value equals a variable. So again here, we can take what's in our absolute value equal to 7x plus 14, or whatever's inside our absolute value could have been equal to the opposite, negative 7x minus 14. And again, we take the opposite of both pieces there, both terms. Now, solve for x. And we solve these equations just like we've been doing since algebra. Once we get to this step, it's just isolating your variable. Here, get all of our variables together on one side. And then add or subtract first. Multiply or divide. We need to check them, and when we check, we plug them back into the original equation with the absolute value. So here I'm going to take the absolute value of 5 times negative 8 minus 2 equals 7 times negative 8 plus 14. Negative 40 minus 2 gives me negative 42, which gives me a positive 42 when I take the absolute value. I'm going to get negative 56 plus 14, which gives me negative 42. Those are not the same, so negative 8 does not work. Here, I'm going to take the absolute value of 5 times negative 1 minus 2 equals 7 times negative 1 plus 14. Negative 5 minus 2 gives me negative 7. When I take the absolute value, I get 7. Negative 7 plus 14 gives me 7. 7 does equal 7. So negative 1 is my solution. Again, show me that this is extraneous. Either write extraneous or give me the answer and then cross it off. And then circle or box in the one that actually works. So x equals negative 1 is the only solution that'll make this equation true. And I will stop there and continue on with the next video.